Hello and welcome to chapter 3.2. In this part, we continue with our story and look at the basic Git concepts, committing and pushing. If you know these concepts, you will be ready and armed for the upcoming chapters. To put now the indexed files which we have in the staging area definitely to our local repository, by linking them to a snapshot and a commit, we have to commit them. Only then we can be assured that our changes are usably and safely stored. Well, that's not entirely true. To be really on the safe side, we have to push the commits then to a remote repository. When you create a commit, you can add a so-called commit message. A commit message is beside the content the second most important thing you can add to a commit. A commit message lets you know what the committer's intention was with a particular commit. When you commit with a clear and precise message, your team's mates will be able to understand what your exact intention is with that commit. But how do we write a good commit message? Well, that's actually not that hard, because you just have to follow the Git convention. Git uses the imperative form in all what it is doing. Init, clone, add, commit. Easy, isn't it? Let's have a look. A good commit message consists of three parts. A short precise title, a body, which can be a bit longer, and a one-liner at the bottom. The title states what the commit will do once it is applied. For that, use the imperative form and ask yourself, what will this commit do once it is applied? And then start writing with an uppercase letter. For example, this commit will fix a typo in the README file. The body then explains more deeply why exactly you did this commit. And at the bottom, you optionally can add a reference to an issue tracker system, for example, a Jira issue number. Good commit messages are like healthy eating habits. Most people know they are good for them, but just a few actually manage to follow them on a daily basis. Good commit messages take practice and discipline to get used to, but once you are in the habit of writing them, you will learn to appreciate the many benefits that come along with them. So from now on, you know how you can impress and inspire your teammates with your excellent commit messaging skills. Let's help Jessica to create her very first commit. First, let us hit Git status to see where we currently are in Git. And Git tells us that we have no commits yet, that's absolutely correct, and that we have changes which needs to be committed. Now all these files here, all these new files are in the staging area, indexed and ready for our very first commit. Now we have two ways how we can create a commit. Simply hitting git commit in a command line here would open up our default Git text editor where we can enter a commit message, or directly by setting the commit message in the command itself by hitting git commit and then -m followed by a commit message. But let's go with the just git commit so that we can see how this works with the Git default text editor, which in our case is Visual Studio Code. So Git will open up now our default text editor, which we have set. And to add a proper commit message now, Jessica asks herself, what will my very first commit do once it is applied? And her answer to this is, this commit will initialize the project. Perfect. And now we can close our Git default text editor again, and we see that Git created our very first commit here. We can hit Git status again to see where we are in Git, and Git tells us we are on the master branch. We have nothing which is open in the staging area to commit, and the working directory is clean. Now that we have done the very first commit, Jessica wants to see the commit history entry. So we do that by hitting git log. And there it is, our very first commit on the master branch. Awesome! So what we can see here now is the commit itself with the hash, the author with username and email address, the date, and the commit message. Let's recap. The local repository is located in the objects folder in the .git directory. So that is here, objects directory. Whenever we create the commit, Git creates a snapshot of the files we have in the index and also a commit object, which then references the snapshot. As we already saw before, the files, the blob objects, are added to the local repository by staging them. Let's go further and have a look at pushing. Once we do a git push, our commit, or commits of course, will be sent from the local repository to a remote repository. As soon we want to work as a team on a development project, we are going to need a Git repository manager like GitHub, Bitbucket, GitLab, Gitbucket, just to name a few, in place. Now it's the perfect time to push our very first commit, which is on the master branch, from the local repository to the company's remote repository manager. We can do that by using git push. But of course, Git tells us that we first need to add a remote repository. So we head over to the remote repository manager of Rockmoon Games. As a side note here, most of the remote repository managers like GitHub, GitLab, and so on work with some nuances almost in a similar way. Let's create a repository called the Bowling Star. For that, we go to this plus icon here, and we set a repository name, the Bowling Star. All other fields, we leave them empty for the moment, and we click Create Repository. Now the remote Git repository manager has created a corresponding repository called the Bowling Star, and all what we need from it now is the URL. So we copy that URL and go back to our local development environment. Here we hit git remote add, and then of course a name for the remote repository. So we call it origin, but it actually doesn't matter how we call it. We could also name it like Black Swan or whatever, and then we paste the URL to the remote repository manager and hit enter. Then a git push again. And now Git tells us that in order to push the current master branch, we have to set the remote repo named origin as an upstream and also provide a name for the remote branch we want to push to. So let's do this. Git push -- set upstream, then the name of the remote repository is origin. That's what we named it before. And then the master branch, because our local branch is also called master and we want to have the corresponding remote master branch. So with this command we do all in one. We actually set the upstream origin master and push it directly to the remote repository. And now we have to enter Jessica's username and of course her password to actually write to the remote repository manager. Perfect! Wonderful! So we pushed our local master branch to the corresponding remote master branch on the remote repository manager. And we can verify that by going to the remote repository manager, refresh that page, and we can see we did it. How cool is that? We push now our very first commit to the remote repository manager here. We can click on the commit, we can see the commit message, and we can see all the content which we have created in this commit here. We head back to our local repository and hit Git Status to see where we are. And we see everything is clear. We are on the master branch and we are up to date with the origin master, which means our local branch is in sync with the remote origin master branch, and we have nothing to commit, so the staging area is clear, and also the working tree, the working directory, is clean, so we have no new changes, no new files yet in the working directory. Now Jessica adds her very first piece of test automation code. Let's close the terminal for a minute, and now let's pretend we would implement an awesome first test for Jessica. Let's do that. Creating a test and say public void Jessica test 1. We open up the terminal and hit Git Status to see where we are. And we have a modified file in the working directory. And that's true, yeah. We actually have now changed the bowling game test class by adding a first test. To add this file to the staging area now, we can hit git add and then the file name, as we already saw before. Or we can take a shortcut and add and commit in one go from here by writing git commit -am and then a commit message by asking ourselves what will this commit do. So this commit will add a first test. So we use the -a for adding everything which is in the working directory to the staging area, and then the m for adding a commit message. So we can hit enter now. We can check that again if the commit is actually created by Git by hitting git log. And we see, yes, our second commit on the master branch is created. And now we can hit again git push to push the modified master branch, which means the master branch with its second commit to the remote repository named origin. So we can hit git push origin. Then of course we have to go to the remote repository manager just to check if it's actually there. Then refresh that page and see also our second commit arrived safely on the remote repository manager. We can click again on commits and see there it is, our second commit on the master branch. We have now done a full round trip of initializing a repository, adding something to the staging area, committing to the local repository, and finally pushing a branch with its commits to a remote repository manager. Jessica is super happy now. She mastered her first task in Git successfully. She's already looking forward of working together with Lisa.